I'm ChosenArchitect, and this is Project Architect 2. Now, jumping back into my Project Architect 2 world, I have big plans for today. Today, I want to get up and running a fission reactor, and this is not an easy task. Before even thinking about setting this up, you do need fissile fuel up and running. And last episode, we got fissile fuel ready to go, and we should be producing enough fissile fuel. I mean, so long as I give this more power, we should easily be able to handle production rates. As of right now, with me giving it 50,000 RF per tick, I am able to produce about 62 millibuckets per tick. But of course that will go up the more power I give it, and it should go all the way up to 256 or so on and so forth, which is going to be a lot for the way that these fission reactors actually work. Now, this isn't exactly going to be the type of fission reactor that you may be used to or may have seen before. Essentially, what I'm going to do with it is I'm going to send it unlimited amounts of water. It's going to be water cooled, and I'm going to set up today some ways to prevent it from blowing up. And I'm going to be emptying the steam into a trash can, and then we just need to worry about getting the byproducts of this process out. That's what I want. I want the byproducts. And then later on, we can hopefully worry about generating some power with some steam turbines. I will note that steam turbines are not required for this setup, but if you want to generate some extra power and you have a little bit of time on your hands, you can 100% get steam up and running and get those turbines spinning and dump any excess steam into the trash can. Now, typically you would use steam turbines to recycle the water, but in our case, we're going to be giving this so much water that we won't have to even worry about that. Now, to be able to meet those water demands, there is one mod that can get it done, and that's integrated dynamics, or integrated tunnels, which is the add-on for integrated dynamics. And this mod can be kind of complicated in itself, but I'm going to do my best to explain how to get everything up and running. Now, first things first, though, I've got to go out and I've got to locate a mineral tree. After a little bit of exploring, here we go. This is the tree that I am after right here. So mineral saplings. Actually, I'm going to grab some of these mineral leaves. I think I have shears. Should have some shears on me. So I'm going to grab those. These are some really nice looking blocks as well. They'd be great for decoration. But I am going to need to grab the logs. That is the important part. And then I can grab the leaves and all the saplings. All of this stuff, for the most part, should have EMC. However, crystallized mineral is really what we need, and the logs are what we need. Because we're going to be producing these mineral chunks, and we're going to need this just a little bit to be able to get the pipes that we're going to need to get this water flowing. Now, getting this up and running is pretty straightforward. We have ourselves a drying basin, and then we're just going to connect a squeezer directly up to it. And the good old-fashioned tried and true method is a pressure plate. So we just need any kind of pressure plate. So I'll use a stone one, for example. Wood will also work. And then you place the log in here, and then you're going to jump on it. And there's also a way that I've shown several other times that show you how you can jump on this and have an armor stand essentially send a redstone signal to launch an armor stand in the air, and then the armor stand come back down and completely squeeze it. But you can see it created some fluid here and produced a block of crystallized mineral, which is exactly what we need. And after gathering about 5 or 6 of those blocks, I'm able to go ahead and upgrade this to a mechanical version, and skipping this process altogether, which is very, very nice. So I now have the an ability to squeeze this right away, and I can go ahead and put the basin here because I still need a few more to make the mechanical basin, but I no longer should have to do this manually. I can just place this in here, and we can set this to automatically send the resin into the drying basin. And I'm still going to have to collect this, but once I have about 4 more of these blocks, I can make the drying version, and it'll do it automatically with power. And voila, there we go. Beautiful. So this is going to take all of that and produce these mineral blocks. It is a whole lot faster, and now we have everything I think we're going to ever need to be able to get into this. So I'm going to need some variable cards. That's like a one-time craft. You won't make those very often. We're going to need a little bit of pistons to make input and output variable cards. So these things right here, and we will use those to dive into the integrated dynamics part, or not integrated dynamics, but integrated tunnels. So integrated, let's go ahead and locate all of this. So here we go. So we're going to need some cables, but not too many of them. And then we're going to also need fluid interface that looks like this. And we're also going to need a fluid extraction on this as well. And that extractor essentially is going to allow us to pull from the interface. So beautiful. To get this to work, there we go. So now we have all of the components technically set aside, so that way we can fill our fission reactor up with water, and we can set the rate with the integrated tunnels, which is, it can go up to a ridiculous number. Now, when it comes to the construction of the fission reactor, we're not going to need too much in order to get this up and running. So I'm going with a 1, 2, 3, 4, 5, 6, 7 by 7. However, I'm going to make this quite tall. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 and 15. I'm going to make it 15 tall here. So it's going to be a 7 by 15 by 7. And you could make this an 18 by 18 by 18, as that is the max size. So just keep in mind, you can make this thing very, very tall. Now for the exterior of this, I'm using the fission reactor casings, which is what this actually needs to be framed with in order for it to be a accepted structure. Now, while I'm building this, I'm noticing that there's a lot of dark areas, but thankfully we have all of this that we can use. These are sparks that are from Cyclic, and they're invisible light sources, which is kind of neat. And so what we can do is we can just put them on the outside here, and notice they light up the entire area. Oh, making sure that we don't have like some super dark spots all over this reactor, which I think would look kind of odd. Now, because I know my dimensions, I know that my vertical space that is going to be inside of this is going to be 13 tall, and I counted out how many, if I was to put this in a checkerboard pattern, there would be, and it'd be 13 times the size of it in here, which would be 13 tall, and that gives me 169, which is what I'm going to need in the cells. And so I could do 13 times 13, which is 169, and that is going to go ahead and get all of those fission fuel assemblies, which are going to be required for the center part. Now, I am going to need also 13 of these rods, and these are what's going to cap off the top. Oh, you know what? I think I did go a little bit overboard, because those top sections actually go here, so it would have been 13 times 12, but oh well, it's not like I'm lacking in any resources or anything. So the interior space is going to look a little bit like this, but I promise you, building the reactor is the easiest part. What actually becomes kind of challenging is managing the byproducts that this reactor produces. And we are going to have to manage all of those like fluids that it produces, and all of the machines that are required to actually process said fluids. Now this last bit, I can put the control rod assemblies in my offhand, use the wand, and boom, there we go. So the control rod assemblies are now in, and I can just go ahead and close off the top with the reactor casings. Now the walls, on the other hand, I want to fill those with reactor glass. And if I did my math correctly, with it being 13 times 5 times 4, that should get me the 260 that I actually need in order to complete that. Now, as far as ports go, we're going to need an insertion. So I believe if this is just set by default, we have the output waste. We want this to be an input. On the back, this is actually where I'm going to handle the waste management. And so I am going to need this to be set to output waste. This side can be the water, so it'll just be regular input. And then coolant is actually where we're going to be outputting the steam. Now, oddly enough, when this is completed, I thought this glass actually connected, but it does not. But whenever you get those particles, it means it is a completed structure and everything is good to go. So long as all the glass is in here. Now, it's, to me, not finished just yet. And that's because we do need a little bit of logic in here, only 5 of these, to actually make sure that this doesn't explode. And so I typically like to use a little bit of redstone in order to do this, and we can set it up just like so. So we're going to have a major logic adapter. This adapter is going to essentially say, hey, shut off the reactor if it receives a certain redstone value. And then these are going to be what actually trigger that redstone. So I'm going to place all of these. I'm going to get that in here. And so we need to go in, and for each of these, we'll set this one, for example, to high temperature. We'll set this one to excess waste. This one will get set to damage critical, and this one will get set to insufficient fuel. Now down here, this will be under activation. And so the way that this is going to work is these, I believe, emit a redstone signal whenever they detect an issue. But this right here, it says right here that it will activate when the reactor is powered and deactivate when unpowered. So what we essentially need is we need this to carry a powered state, and we need these when they emit a signal to unpower it. And so we actually need a NOT gate. So now what I need to do is I'll go ahead and use some redstone links to make this nice and clean. We just need to give it some sort of indicator of what it is. I'm just going to use the enriched redstone here, and I'll set this value to enriched redstone. And these are going to send the signal. Notice this one already has a signal sent. So it's going to send that signal, and we need it to go to a receiver. So just down here, we can go ahead and place our receiver, put it in receive mode after setting the signal. And we can do that by shift right clicking with our hand. And notice that is sending out a redstone signal. Now, what we can do is we can build a little NOT gate from this. So I should be able to receive a redstone signal here. And I think I need to break this. There we go. So there's our signal. And I'm just going to have this send into another block. So to create a NOT gate, typically you would just place down, for example, a block, right? And then you would power that block, and then the redstone torch would go on the outside. And notice that that redstone torch is now off, right? Which is what we actually want. And so we just continue our signal here out to the outside. And what we can do is set up another redstone link, just like this. And that is going to be the one that goes to this one. So we'll put this in receive mode if I have an empty hand. That's going to be in receive mode, and we'll set this, for example, to the tiny redstone icon. That's fine. So there we go. So technically, this is now set up. So what should happen, for example, if this one wasn't connected, that should be powered. And you can see it is powered on, and that one is now powered on, which is perfectly fine. We don't have any fuel in here, so it's not going to work. But we will notice when this is back on, that when we put this together, that tiny little redstone circuit actually shuts it off, which is just hilarious, and I love that. But now believe me, you're going to want that failsafe up there, because if anything fails, any of the major parts of this fail, that is going to hopefully keep this reactor from irradiating your entire base. So now that the hard part is essentially done, let's go ahead and talk about how we're going to get water into here and how we can make this incredibly fast. So this is the coolant port, I do believe. We need the input port. So I'm going to use a sink, and this is just the magic sauce to this. So we're going to place a fluid interface, right, just like this, onto the sink itself. And then we're going to use a fluid exporter, which is going to export out of this, this fluid interface, which is essentially turning this sink into like an inventory that it's reading from. And so we place this on here. And then of course we need to connect this with a cable. Beautiful. Now is when we're going to place a variable card inside of the export all fluids. So you just need to place it in there, and that should start to fill with water. But notice it's not very fast. So the way we're going to fix this is by going into the properties of that, and we're going to slide on over here to the fluid transfer rate. And I'm going to change this to a 9, and I'm essentially going to go 999 until this check mark stops, right? That check mark has stopped, and then I'll go back one. And there we go. And so with that fluid transfer limit set, we back out, and notice how quickly that fills up, because that transfer limit is insanely fast. And all this cable does is just sends that water as fast as it possibly can. It is just ridiculous, and honestly makes this whole setup way more trivial than it would be. Now to handle the steam production, honestly, it's just as simple as placing a fluid trash can on the side. And believe it or not, this auto outputs the steam. So it's going to auto output it directly into a trash can. I know I'm not producing power by doing this, but later on we will figure out potentially a way to generate power. I just have to get all of the infrastructure set up for the turbines, which is honestly the hardest part. Now, speaking of the hardest part, dealing with waste and how we're actually going to use said waste back here. So this machine is going to turn fission or fissile fuel into nuclear waste in this process. So the nuclear waste can be broken down inside of an isotropic centrifuge and a solar neutron activator. Now, the solar neutron activator is the reason this dimension is an internal day dimension. It's because we need this in order to make polonium, and it needs sunlight in order to work. That's all it does. It doesn't get powered or anything like that. It just needs daylight. Now, this does need daylight. So what we're going to do is we're going to essentially have both of these machines next to each other, or not exactly next to each other, but beside each other. And we're going to try and split up the waste to both machines. So that way we can produce plutonium and produce polonium, which we're going to need both. Now, once we have that done, that's where we need to go into this process here. So each one of these fuels are going to produce different things and be done inside of a PRC, or a pressurized reaction chamber. So it's going to receive that waste product that is processed even more. And then we're going to feed it also fluorite dust for both of these processes, which, by the way, these are both the same for both of them, except one produces polonium and one produces plutonium pellets. Now, the biggest issue of this is the spent nuclear waste. Yes, this is a big problem, but we can actually just send all of that to the radioactive waste barrels, just have a bunch of them. And that's one way to get rid of it. But there's actually another way in this pack that's pretty cool. Now, before we get to that, we're going to have to get all of this stuff set up. Oh, and by the way, for the solar neutron activator, remember how last episode we set up the HDPE sheets? Well, yeah, all of that is required in order to even get this step up and running. And so if you didn't check that out, I highly recommend doing so. As you can see, I even scaled this up a little bit more, and it doubled the rate that we were producing these sheets. And you can see this produces them incredibly quick, and also produces a significant backlog of ethylene. So I did a little bit of configuration of the machines. Essentially, I have my gases set up so that way this will receive the input from the back. So if we do a tube from Mekanism, in which I will upgrade this, if we do a tube back here, I want the tube to essentially split. And it doesn't exactly work that way, like it won't 100% split, but we can control these two machines, and eventually we'll just kind of let them be, and we will route this pressurized tube somewhere else, and where it will eventually be turned into like running just straight through this machine. But that'll be later on down the road where we start to produce antimatter. But for right now, we're trying to produce polonium and plutonium. Now, to get rid of the waste, which is the big issue here, right? This waste. So down here in the gases section, I have the waste set to the bottom. And what I'm going to do, and I've heard this through the grapevine, through the Discord, you guys have shown me some kind of interesting things. We can utilize our applied energistic system and the way that it handles the Mekanism gases to actually destroy it inside of the matter condenser. So we have it underneath the destroy item section, which will also take in fluids, and we'll use an export bus on the bottom here. But I've created a subnetwork, and I've kept my colors separate. So I have my cable, and I'm powering this subnetwork of 8 channels right here. And the way that we're going to do this is we are going to use storage buses on the bottom here to connect to this, to essentially show and give an inventory to that waste. And then we're going to route that waste into the bottom of our condenser here with an export bus. So if we look up waste, we should be able to drag that into here. And so now we have spent nuclear waste inside of the export bus, which should export that spent waste directly into the matter condenser. That should be the cleanest way I've ever done this. And now, as far as the items go, we'll just have the drawer directly on top of here. And we'll just go ahead and send that directly out through the items. We'll clear this and make sure the top is the output and turn that on. Now, the right side is going to be the input for this machine. And then over here, we'll do the exact same thing, but the left side will be the input. Make sure auto is turned on. All of that should hopefully work. Same with our gases. Everything should now be set up. Famous last words, because if I do make a mistake, the chances of creating chaos in the base in this dimension is very high. Now, I am going to need a crusher in the middle because this is going to receive fluorite, and I'm going to go ahead and clear the output here. We're going to set the output to both sides, auto eject, and I'm going to set the top. Yeah, the top should work for input, and I should be able to pipe fluorite into here. Now, above my solar neutron activator up top here, I do have a sky hole. essentially allowing it to have access to the sky, which should work just fine. I have everything now powered, ready to go. This is starting to fill up. Oh, fingers crossed. This is honestly a big, big endeavor here. But all we have to do now is just fill this with fizzle fuel. So an entangle porter is all I need because that is currently where my fizzle fuel is stored. And we should be able to attach it directly to the front here and have it auto export into this directly. So by selecting fizzle fuel, we should be able to set that. And then inside of our gases configuration, we'll clear and make sure this is set to output and auto. And that is going to kick it on. Now I'm going to shut it off for right now because there is a couple of things that I need to do. For one, I definitely need to make the reactor, the fission reactor sound turned way down. So I should be able to turn this on. Okay, so now it's up and running. Things should be flowing. We noticed that waste should be moving and that should be moving. Let's go ahead and stop this for a second and just sort of take a look at everything going on back here. So that's empty. That has polonium in it, which is what we want. And nothing has been processed yet, simply because we have not given it enough to process anything. So something that I've done in the past is I've just let them both run, but you can actually toggle these on and off by using this button right here to change its redstone mode. But for right now, let's go ahead and toggle this back on. And what we should see is if we go into the status here, we can start to adjust the rate. So if I set this to 50, this is going to change the rate to 50 millibuckets a tick. And you kind of got to be careful when doing this because you do not want to set it too high. Notice the water dipped a little bit there. But with this going at that rate, you can see this is now actively working. Both of these should be up and running. And we should see this all flowing. And if we get this correct, we should see a product here. And then we should not see any waste byproduct here. Oh boy, but that is exactly not true because there is byproduct there. It is set to destroy right now, and maybe it takes some time to ramp up on the export here. Oh, I could be completely wrong. If so, I think we would still be fine. I just need to essentially shut the reactor off and see what I did wrong here. Okay, so after doing a little bit more research, I completely did this wrong, but we should be able to easily fix this because there's nothing connecting these just yet. So essentially what I need to do is the storage bus actually needs to be on the matter condenser and giving this a storage, basically creating a storage here. And then we are going to send our waste in here with applied energistics, what are they called? I've got to find them again. There we go. The ME interfaces. So this being a subnet, the only place that this can go is going to be into there. And so by putting an interface here and having this auto export, that should now have dumped it. Oh my goodness. And it does. There's a easier way of getting rid of waste. That is kind of ridiculous now. So now I can go ahead and turn this back on and we can start to hear the wash. It sounds like a dishwasher running. But this should now be working. We shouldn't see any waste because it is voiding it. I don't think I've ever played with this where I was able to, for example, void the waste outside of using waste barrels. So this is a pretty interesting and clever way of doing it. And thanks to everyone on the Discord. Now this is fantastic. Now looking at this, it does look like it is evenly distributing it, which is very nice. These are both going up at the same rate. Everything's flowing in like I would hope it would. Very nice. And we have to wait until we get a certain amount of this built up. And so just kind of letting it run as we continue to do things is going to be pretty good. And I'm going to leave it for right now at the 62 burn rate, which is what I believe is how much we're generating in our fizzle fuel production, which is back here. Because if I take a look at this, for example, we will see that it is kind of bouncing between the 63 and 62 point. And I believe this is what actually tells you how much you are producing. And you can see we are limiting it because of the power. So if I was to put a higher tier gate on here, we would be generating definitely more, but I don't need it right now. What I am going to need is a lot of it whenever we start to produce antimatter, which we have to kind of wait a little bit for these to build up, because we are going to need the pellets in order to make an SPS, which is how you produce antimatter. Now, antimatter is all cool and well, and we're going to need it for the end game, but there's a lot of cool mechanism things that I want to actually make that do involve these pellets, and we can actually take a look at a few of those. For example, there's the Mecha tool, which I think is pretty darn awesome. It is an upgrade for your main tool and has some upgrade capabilities that you can add to it, which are going to be very, very handy. And then there's also like the bows and stuff, but there's upgrades for it in here. So the same mod that adds all of the plastic from Mekanism Editions, which I absolutely love, by the way, they add some other cool things. For example, there's the Mech Tana, which does 50 damage. There's also the Mech Bow, and you may think, well, that seems kind of useless to even have that if you have a Qatar, but it's just some other cool things that you can play with. Now, the Mech Armor ultimately is the armor that I want. And Mech Armor also requires these polonium pellets, and it also requires these induction cells and things like that, which require some lithium, and lithium's honestly a pretty easy setup to get going. Now, speaking of lithium, I can actually go ahead and get that set up. Now, this does require you to build out a 4x4 area for this. So 1, 2, 3, 4, just like this, and then 1, 2, 3, 4, making sure that you have at least a 2x2 space interior, and that is very specific. Like you can't build it any bigger than that on the interior space. Now, you can take these up to 18 blocks tall, which will increase the speed at which it does conversions. And the way we make lithium is by using 2 of these structures, which are going to be thermal evaporation chambers. And the way we do that is we take this and we feed it water. That produces brine, and then that brine gets turned into lithium, and then we need to crystallize it. Now on here, we're going to need a controller that goes on this. So we have a face right here with a controller, and then we're going to need an input and output, for example. So right here on the side, I can have an input for our water, our initial water source. And then back here, what I can do is I can have an output for the brine. And then over here, we can have an input. This will be for the brine. And then over here, we can have an output, for example, for that. But to be able to heat these, there's a couple of different ways you can do it. They can just be out in the sun, and that works. You can put solar panels on them too, on the corners. That also works. But in my opinion, if you have power, I definitely recommend using a resistive heater, but you are going to need an evaporation valve in order for the resistive heater to send heat in here. So if we take a look at a heater, the heater will heat this up and get this nice and toasty, allowing these processes to flow much faster. And honestly, I like to have these directly connected to each other, where you could get by with just using one resistive heater. Now on the resistive heater, they are going to need power, and you have to set the power that you want going into these. For example, we can do like 200 RF per tick. 200 RF per tick. There we go. And we're going to see that heat value is going to start to increase. And we'll worry about what our actual power needs to be set to once we actually start getting the fluids flowing in. You know what? Instead of using pipes, I'm actually going to use some entangle porters for this. I was going to use entangle porters for the output here, but apparently this does not auto output, which I find to be very interesting when most of these machines do. Now for the final step, we're going to take this and we're going to set it into decondensating. We're going to turn the liquid lithium into a gas, essentially. We just need it to output to the top. So the input will be from the side on the fluids, which is already set, just like that. And then the gas, we're going to output to the top and make sure auto eject is on. And that is going to go into the crystallizer. And the crystallizer needs to be set to gases here, and making sure the bottom is an input. And we need the item that it produces to be output automatically to the top and auto ejected. And that should be pretty straightforward. We should be able to slap a gate on here, and that should just work. I do have to get pipes, however, piping into the side here, but outside of that, should be looking pretty good. There we go. Now we have the lithium going in, and that is decondensating and is storing in here, which will get converted into lithium. And then I'll just put a barrel. And just like that, we now have some lithium being produced. And so, believe it or not, we have gotten through today's episode with a ton of things I hope you guys learned. Whether that was about setting up a fission reactor and getting it all up and running, or whether it was about diving into how to produce some lithium and what all is going to be needed to do in the future, or my favorite thing from today's episode was actually figuring out how we could dispose of waste and actually make it just instantly disappear. Honestly, that's a game changer. And so with that, I hope you guys enjoyed today's episode. And of course, if you did enjoy it, be sure to click the subscribe button if you haven't already, and give this video, guys, a huge thumbs up. I would really appreciate it. And with that being said, I think it's now time to thank the amazing supporter of today's episode. And that amazing thanks is going to go out to Bacon. I hope I said that right. Thank you so much for your amazing support and choosing to support me over in the Discord by becoming a Discord premium member and supporting in one of the best ways possible by becoming a Discord premium member. Thank you so very much. I do appreciate you guys, and I thank you all for watching, and I look forward to seeing you in the next one. And of course, as always, thanks for watching. Bye.